Okay, so quick recap from previous lesson. This is looking at the knowledge and skills from 8.5. If you haven't done this lesson yet, please go back and have a look at it. So we were talking about catalysts and the fact that they change the rate of chemical reactions but are not used up. That makes them very useful industrially. The fact that different reactions need different catalysts. Catalysts are specific to a reaction. Therefore, enzymes, unsurprisingly, are a type of catalyst. And the way they work is by providing a different or alternative pathway for the reaction that has a lower activation energy. And then we drew a reaction profile for a catalyzed reaction. Hopefully you can remember how to do that. And we realized that catalysts, even though they do have an effect on the rate, they are not included in the chemical reaction, or sorry, the chemical equation for the reaction. And the fact that in terms of activation energy, they lower or provide a different pathway with a lower activation energy. So the knowledge and skills we're looking at today, well, if you look at this first statement, it says we're going to investigate how changes in concentration affect the rates of reactions by a method involving measuring the volume of a gas produced and a method involving a color, changing color or turbidity. All right, basically that means how much you can see through it. This is essentially the required practical, so you could be asked to do either of those two things. All of these other statements are about graph drawing, and we've actually covered those before, but we're going to have a quick look at those. So, quick recap on the methods that we've covered for measuring rates. First of all, this is the mass loss method. This is when you measure a reaction that produces a gas, and the gas escapes out the top. So, the faster the reaction, the faster the mass will decrease. Second method for measuring the rate of a reaction that produces a gas would be to use a gas syringe, and obviously this is now everything sealed here. So as the gas is produced, it comes into here and the syringe pushes out, and obviously the faster that is pushed out, the faster the rate of reaction. Over here, this is the third way of measuring a reaction which produces a gas. Again, sealed here, but open at this end so the gas can escape into the water. You then have your upside down measuring cylinder or gas collection vessel of some sort, and you measure how long it takes for the water to be displaced, or if you like, for the gas to replace the water. And obviously the quicker it does that, the faster the rate. And finally, this rather unexciting looking thing here, this is the one in which you use to measure how fast a solid is produced, or if you want to use the jazzy word from the other side, to measure the turbidity of this particular solution, so the amount you can see through it. And basically you put your chemicals in, and that crosses on the piece of paper underneath, and you time how long it takes for the cross to disappear. And of course, the faster the rate, the quicker that cross will disappear. The easiest thing to do in terms of looking at how these types of questions work is to actually look at an example. So here's one between some magnesium and hydrochloric acid, and here's your chemical equation. You've got some solid magnesium, some hydrochloric acid solution to form some magnesium chloride solution and hydrogen. So this is a two-parter. First bit is looking at two observations, so things that you see. Remember, observations are literally what you see. Please don't write things like you can see hydrogen. It's not hydrogen that you see, it's actually the little bubbles, so just be careful about that one. And the second part is the bit we really want to look at, which is the actual method as to how this would work. Okay, so this is my notes for this particular question. You'll notice the first part is slightly different in that I had to write the word equation, but that was obviously given to you on the previous slide. Second part, two observations. Well, you don't write hydrogen, you write bubbles of hydrogen, because that's what you would see. Or if you would like to use the fancy word, that's effervescence. How do you know? Well, because you've got a G over here. The other thing in this case is the magnesium that is a solid here. There's no solid magnesium over here, so it must have dissolved. So what will you see? You will see the magnesium disappearing. Now, the bit I want to focus on though is this second part, which is the planning section. This statement here is a pretty common statement you will see. So in this question, you'll be assessed on using good English, so that's get your spelling and punctuation sorted out. Organising information, that basically means writing a step-by-step, very clear to follow method. And using specialist terms, that's all about naming your equipment properly where appropriate. So what's the actual question? It says, the student investigated how the rate of this reaction changed when the concentration of hydrochloric acid was changed. So the concentration of hydrochloric acid is the thing that you are going to actually be changing in the experiment. So if that's the thing you are going to change, that is the independent variable. It says you're investigating how the rate of this reaction changed. So that's the thing that you're trying to find out. So you're going to be measuring the rate of reaction. So therefore that is going to be the dependent variable. It says our plan should describe how you'd carry out the investigation to make it a fair test. Now, you might have noticed on the previous slide, it said to gather valid data. They tend not to use the words fair test anymore. Valid data basically means the same thing. So if you see the words valid data, you should be making sure you're writing your control variables, your quantities, and your independent and dependent variables. So that's the same thing. So fair test, valid data, that's the same kind of thing. And the measurements, well, what actual equipment are you going to need? So that's the sort of things you want to be thinking about. Like I say, if you see the words valid data or valid test, make sure you explicitly write down the independent variable, the dependent variable, and what you're going to keep the same. So if you're thinking about how you'd actually approach this, first thing I would do is actually write those down. So the independent variable would be the concentration of acid. That's what you're going to change. Dependent variable is going to be the, well, what is it? Well, we're producing a gas. So it could be volume of gas produced. I guess it could also be the mass if you're doing a mass loss, but volume of gas produced seems like a sensible choice. And control variables, well, when you're thinking about control variables, particularly with rates ones, think about the other factors that you know that affect rate of reaction. So you should know, obviously, that concentration affects it. That's what we are changing. So therefore, all of the other things that affect rate should stay the same. So if you think back, first of all, if you've got a solid, surface area. So the surface area of the magnesium. So how are you going to make sure that's the same? Well, obviously you could have the same size and mass of magnesium, but essentially you need to make sure the surface area is the same. What else do we have? Well, if you've got a solution, obviously concentration affects it, but that is our independent variable. So that is what's got to change. So think about what other things about this would alter the number of particles. Well, as well as the concentration altering the number of particles, the volume is going to alter the number of particles, isn't it? So you're going to have to keep the volume of hydrochloric acid the same as well. Other factors, of course, well, the temperature of this whole system, because clearly if it gets warm, then it will increase the rate. So keeping the temperature the same, it's also pretty sensible. So those will be pretty useful things to write down here for your control variables. Then essentially in terms of the actual method itself, like I say, some kind of measurement of gas syringe, or the collection of water. I tend to go with gas syringe because it's pretty straightforward. So you're going to be measuring out a set mass of magnesium, or if you're using ribbon, a set length of magnesium. You're going to be measuring out using a measuring cylinder a set volume of hydrochloric acid of a known concentration. Then you're going to be putting the magnesium into the conical flask, adding the hydrochloric acid to that magnesium, inserting a bung in the top, making sure it is connected to a gas syringe. Even though it doesn't say here, drawing a diagram might not be a bad idea. And then, of course, you are going to time to see how long it takes for a specific volume of gas to be produced. Once you've done that, you would then repeat the experiment using different concentrations of hydrochloric acid. Probably a sensible number of different concentrations to use would be, I don't know, maybe 4 or 5, and then have a look at what those results will tell you. Right, so the actual mark scheme for that slide is as follows. You'll notice it's a very generic type of thing with a level 1, level 2, level 3. You will see this a lot in the more recent exam questions since they changed the spec. This is how they're doing these longer answer questions. So if you want to get the top marks, which I'm sure you do, you need a workable plan, whatever that means, which includes the change of concentration. Remember, that's the independent variable, so you've got to include that, and how to measure the rate, and how to keep everything fair. That means control variables. basically, if you're looking at lower marks, you basically missed out some of these things. So notice things they wanted, add the magnesium to the acid. That's got to be in there. Obviously, you need to say how much of these things, but that has to be in there at some point. How you're going to actually time the reaction. Now, of course, you could count bubbles, but I would say that's a pretty shabby idea in this case because there's likely to be pretty fast. This is not a pondweed situation. All right, so a gas syringe would be much better. And of course, you are going to be changing the concentration. Steer away from that. Change the concentration of the acid. Control variables, there they are. Down the volume there. Now, this is a really weak mark scheme, to be honest. This was on one of the, I can't remember, it was either a specimen question or it might even have been the old spec. Detail is what you want in these answers. All right, and we'll see that on the next example. So before you have a go at actually having go one of these questions yourselves, it's a kind of general load of things to do with planning experiments. As I said, this is a very, very common thing you'll see at the beginning. Spelling, really try and be careful, organize things clearly, and make sure you're using the correct names for equipment where needed. This goes for any planning experiment, not just a rates one. So if you're talking about rates, it's going to be obviously one of these things here, and they're going to tell you what it is. All right, so they want to investigate how the rate of reaction changed when either the concentration or the temperature or the surface area of something was changed. All right, so if you're thinking about variables, the rate of reaction is likely to always be the dependent variable, and one of these factors here that you know affects the rate is going to be the independent variable. So it could be concentration of hydrochloric acid, or it could be temperature of hydrochloric acid, or surface area of calcium carbonate, or surface area of magnesium. So these are things that could vary. Important thing when writing a plan, it seems blindingly obvious, but it needs to be something that you can actually use, something that you can put in front of someone, they can follow it pretty much blindly to the letter, assuming they have the equipment in front of them. Assume absolutely nothing. Right, so make it as clear as possible. This here, so valid results, like I say, you're unlikely to see fair testing anymore. Valid results is what they're going to be writing. That essentially means write down the independent variable, write down the dependent variable, write down all your control variables, and you'll get your mark for that. Describe the measurements, so make sure you're using the correct equipment, so measuring cylinders for volumes of liquids, balance for masses, gas syringe obviously measures the volume of gas, that sort of thing. This one down here, to be honest, it's only really if they state it. Yeah, I mean, if it says you must include safety measures, you will be basically capped at 2 marks if it's a 6 marks question. So make sure, just have a little, keep your eye open for that one. Right, so this is now a kind of generic mark scheme, the sort of thing that you would be looking to try and do to get your 6 marks. So again, it's a workable plan including the change of something, whatever it is you're investigating, maybe temperature of acid and measurement of rate, and make sure you got your control variables. Here you go, there's your valid data statement. Make sure they're all in there. Make sure these things are named correctly. And when it says step by step, I would actually suggest writing step 1, do this, step 2, do that, etc. Right, so using all that information, let's see if you can have a go. This is a reaction between sodium thiosulfate. You might remember that from a few lessons ago. You should be able to work out which one it is in this particular reaction, and how it reacts with dilute hydrochloric acid. Tells you it becomes cloudy, gives you an equation. First job, you've got to explain why it becomes cloudy. Now, obviously, that's not a method writing thing, but you should be able to have a look at what's going on over here and decide why it becomes cloudy. Then this is the bit that's all about the planning. Plan an investigation to show how the concentration of the sodium thiosulfate solution affects the rate of reaction with dilute hydrochloric acid. Your plan should give valid results. So notice there's a lot of similarity here. They haven't actually got the statement about good English and all that jazzery, but you really should try and make sure that you do all of the things that were mentioned on the previous slide. So this one, pause it, have a good go at writing that, and then the next slide is going to have the specific mark scheme for this investigation on it. Okay, so this is the mark scheme. So the first bit, I guess the only thing that's a bit annoying is how do you actually get 2 marks out of it? Well, number one, you had to say it's the sulfur that's being formed. so to identify the sulfur as being a solid. The word precipitate, you might remember, is the fancy word for a solid that is produced from a solution. Right, so the bit that we were really looking at was part B. Again, you'll notice there's some banding stuff going on here, so to get 5 or 6 marks, you would have a level 3 answer. Notice the language, valid outcome, right, that means the control variables are all in there. So if you don't include your control variables, chances are you are going to be capped in the sort of 3 to 4 zone. So in terms of how this is going to work then, first of all, you would measure out a volume of sodium thiosulfate. That just means that if you wrote a number associated, that's obviously fine. So a sort of, I don't know, 10 centimeters cubed, 20 centimeters cubed, something like that would be fine. I would actually suggest writing with a measuring cylinder there as well. Place that sodium thiosulfate into a conical flask. Then you're going to measure again, set volume of the hydrochloric acid. Once again, 10, 20 centimeters cubed is fine. It's quite important that you don't mix these two things yet though, because if you do that, the reaction will start. So before you mix them, the flask with the thiosulfate needs to be placed on a cross. Now you could have written between a light sensor, I guess, but if when we do this, we're going to be using actually a cross. Then you add the hydrochloric acid to the flask, so that needs to happen after thiosulfate flask on the cross. Swirl, always good to mix things in chemistry, makes good chemical sense to make sure everything's mixed together. All right, start that stopwatch or stop clock. I would say the word immediately should be there. I mean, this should happen as soon as those two chemicals are added. Then you're going to measure the time for the cross to disappear or for it to no longer be visible. And this here always makes sense. Repeat and define the mean. Obviously that enables you to eliminate errors and anomalies. And now you're looking at, so that's the kind of base method. Then to get this valid outcome stuff, you need to be talking about obviously the repetition with different concentrations. Now I would explicitly say that that was your independent variable because that is what you're changing. Then of course, if you think about variables again, the thing you measured, the dependent variable, well that will be the time for the cross to disappear. And then your valid outcome, your control variables, these guys down here. So concentration of hydrochloric, now just think about it, because of course if the thiosulfate is what is varying, the hydrochloric acid must stay the same. And of course the volume of the hydrochloric acid and the volume of the sodium thiosulfate. Right, a couple of points about some of these other things on here. This I would avoid. It's only really on there because if you look back at the equation, you'll notice there's some sulfur dioxide formed, but it really is, you don't see bubbles. Gas syringes is not an appropriate way of measuring this one. So I know it's on this case, but I'm not entirely sure they would give that normally. And again, here, I guess that's just there just in case you come up with something cunning that actually will work. So you can ignore those things as well. This down here, well, what they're doing, that is essentially changing the concentration, isn't it? So you could actually say, well, if you were using 20 centimeters cubed of sodium thiosulfate, you could on the second run use, I don't know, 15 centimeters cubed of sodium thiosulfate and 5 of water. So total volume is the same, but you've diluted it. Right, so this slide is just a quick reminder about using graphs to calculate rate. These are looking at reactions where gases are produced. So first one, you look at the volume of hydrogen, so that will be the product that's produced over a set time. Remember, this one is going to go through 0 because at time 0 there is no hydrogen because it's a product, and then you have a particular fast rate of reaction at the start, and then the rate gradually slows down until the reaction stops around about 60 seconds-ish. All right, well, a bit before. Why does it slow down? Well, if this was an acid and metal type reaction, then the acid particles would slowly react with the metal particles, and then over time there'd be less acid particles, so the reaction would slow down. Two possible ways of calculating rate. You're either calculating the average rate, so if they wanted the average rate over 50 seconds, for example, you would go volume, and for the sake of argument, let's say that's 100. So it will be 100 divided by 50, which will give an average rate of 2 centimeters cubed per second. The other possibility is they might want you to give the rate at a specific point, so I don't know, like 25 seconds, like here. And to do that, you'd have to draw a tangent. So you get your ruler and make it as big as possible. So all the way to the y-axis, right, and all the way up there. And then draw your y over x triangle and work out the gradient of that tangent. Similarly, they could give you one where they look at the mass of reactants over time and how that decreases because the gas is being given off. It's very, very similar. So if you were doing the average rate after, I don't know, 10 minutes, you would have a look at the mass lost. And what's that? It's called 122. I don't know what's that. That's 2.2 grams-ish that have been lost. Therefore, your average rate would be 2.2 divided by 10, which will give 0.22 grams per minute. So that's the average. Or again, they could ask you for a specific, so I don't know, after 5 seconds, you then have to draw a tangent, and again, nice and big all the way to the y and the x-axis. Big old triangle, that's really bad, but big old triangle, and do y over x to get your rate at a specific point. Okay, now there's an absolute shed load of graph questions for you to have a go at. So yeah, that's your next job. Have a look at some examination questions. Final slide, just a quick reminder of the actual spec statements. So you're supposed to know how concentration affects the rate and how that could be measured using volume of a gas or change in colour. This, like I say, is the RPA, so this is the bit you were looking at with that planning section. And then all of these down here are all about graph interpretation. So if you have any specific questions about any of those graph questions, because I do know there are loads of them, and some of them are a bit trickier than others, then do ask.